Alrighty. Hello everyone, and alright, we look to be good right now. Hello everyone, and welcome back to another YouTube challenge. Today we're going to be kind of continuing on with what we did last time with the static file server. We're going to be moving towards dynamic web servers, so ones where you can customly inject data into, so kind of like an API, and we're going to allow the ability to have custom routes that map to different things, and you can pass in route arguments and query parameters and all of that stuff. So we're going to start just by looking at how to manage these routes, because that will serve as the basis of our dynamic web server, because we already have the networking in place with our static file server and the content delivery templates in place with the static web server. We just need to allow it to actually serve content dynamically. So we'll start just by looking at a route. So when you make a request to a web server, say it's going to be like, I'm blanking here, test/hello, or say get user slash, and we'll say user slash the ID, so we'll do 23 slash devices slash device name. Or sometimes you have query parameters where it'd just be like index text is equal to hello. So these are all valid routes, and you can do whatever you want with them. But we need to figure out how we're going to be able to parse this so that we can programmatically send a request that may not have the same value here, or the same value here, or the same value here, where we can't just do a raw string comparison for all the routes. We might also want to say get user slash 36, or user slash, let's say, Michael. So we'll get a user by their name, and we might not want to have an integer there, but there may be several different ways to do that. So what we're going to do is we're going to deconstruct this route and allow us to essentially pass in a string, because when we get the URL, if it's a number or a string or letters, it's still going to be a character array. So we need to figure out a way to funnel that into the proper route. So for example, if we considered one, we'll start with our root. That's just the / is the one root for all the routes, and we're going to kind of think about this as a tree structure. So we'll go over how we're going to do this as per usual in OneNote, and then we shall write the program. So we have our root node here, and the best way that I've been thinking about this, and when I started to look at this, I had heard the words regex before, and I'd also heard, and I'd also done stuff with dictionaries mapping routes, but the dictionaries were all static, and you couldn't dynamically get a value into it. So I was thinking, well, why not just use a tree? Because it makes the most logical sense. You have one node which represents one state or one possibility, and that branches off into multiple states or possibilities. So for example, we have user. So if we were to request /user, we would start at the root node, and then we go and find the user key. And that's just for a simple hard-coded route, and that's just what we're going to call a plain route. And we could also have a test here. We could also have something like, I don't know, endpoint, oops, I can't write today, endpoint 3. And then from user, we have devices. So if we requested, or actually, no, sorry, not devices, we would have an argument here. So this route here would be dynamic. It would be based on the argument. So it could be something like, oops, where we would pass in an integer. Oops, let me just draw that so it's easier to see. So this is an argument here. And what this route will accept is anything that's user slash an integer. So user /5 and user /20 and user /30, and they all get funneled into this route. And then from here we can also have further subroutes. So let's say something like devices. And this can get a list of all devices, or we can just want to get one device. Oops. And then from device, we would want to further pass in another argument, which is another integer, which may be the device ID. Or we would also want to be able to pass in a device name, because maybe we're storing both. So this would be a string. So either way, you see all the possibilities here and how flexible this structure can be. Because with this one structure, we have every node represents an endpoint, and that endpoint can take arguments, or it couldn't. Like, for example, we don't want /user to be an endpoint because it doesn't have any route arguments. We don't know what user we're looking for. So this would be a null endpoint where there wouldn't be an action associated with it. Same with user /integer /device. There's no action associated with it. And so we would essentially just skip these. But when we get to, say, an endpoint that does have an action with it, so this would return, say, a page, a user page. So this could give us here a picture of their little body and their name, blah, 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 blah. Whatever you want it to be. This could be the action here. But we can essentially just associate different actions with an entire tree, and this is endless. These endpoints are endless, because it's going to end up being a dictionary. But we're gonna look at how to configure the dictionary properly, because you do need to have a mapping at some level, no matter like how deep it is. There does need to be a dictionary to allow for mapping. And we'll see. We're going to actually have two separate dictionaries, but we shall see how that works. So yeah, that's going to be essentially how we parse this. We're going to get a route. We're going to split it up based on the slashes, divide it into a tree. And this will we'll be able to, we will, how should I say this? We're going to be able to add to this dynamically, and we'll probably won't want to take away stuff, but I mean, we can also that functionality is also in there. It's definitely possible, but the point is we can add whatever we want, and it's easy to traverse down this based on the mapping. The only tricky part is how are we going to parse this? Because, well, how do we detect that an integer is an integer? Because, like I said, it's still just a string of characters. So we're going to have some sort of class to help us, or a couple functions to help us parse what type an argument is and get the actual value from that string. Because, like I said, you can have multiple types, and there will be a priority. So, for example, if we passed in the route user /27 /device /36, 36 is a string and an integer. However, since it's numbers, we want to get it as an integer first. And same thing with parsing a double versus an integer. A double will be able to parse 36, but we don't necessarily want it as a double. We want it as an integer. And then we could also do things with GUIDs, which are just globally unique identifiers. And we'll look at how to prioritize things. But for now, let's start by writing the helper functions to actually to parse these arguments here. So I'm going to go ahead and create a project in Visual Studio. And I'm just going to call it Web Server Routing. It's a .NET Framework console app. I have it in my folder here. I'm just going to go ahead and hit create. And that should take a second. It's taking a while. All right, so we have our program here. Good. Let's go ahead and create a new item, and we're going to call this. We're going to have a class, and it's going to be called. What do we want to call this? This will be the first class that because we'll start by just being able to parse arguments from a string, and then we will integrate that with our tree structure. Or we could go the other way around. Let's do the arguments first, just so it's easier to plug into the tree, and we don't have to change much of the tree once we do it later. Okay, so we'll call this class argtype. Oops, that did not want that at all. Argtype. There we go. And we'll make it public. And this episode's also going to include a lot about C#, which will be very cool. So in an argtype, we essentially want to have we want to have a couple things. So we want to have a way to identify the argument or the type of the argument, and we can just use the C#'s type class. So public type, and we'll do some auto-implemented properties. You can get it publicly, but we only want to be able to set it privately. So this automatically gives us a way to set the type, and we'll see how it works. But you can essentially just call in program. We can say argtype is equal to new argtype and whatever, and then to set the property, you can just say argtype dot type, and this will get you the property, but we can't set it because that's private. So argtype dot type is equal to type of string, for example. You can't do this because this is private. It's like the accessor is inaccessible. This here is just invalid syntax. So we can just say like var t is equal to that, and that'll be good. So you can get it, but you can't set it unless you're in the actual class. And then we also want to have our parsing function. So we're gonna predefine a couple of standard arguments like integer, string, double, GUID, and we'll also do GUID. But then this framework will also allow us to expand beyond that, and we can use it to parse more complex objects, maybe using JSON or the whole Newtonsoft project that comes with JSON. It's insane, but you can just it's very easy with C# actually. So we're gonna have a parser, and the type of this parser is going to be a delegate function. However, we're just gonna represent it as a function with taking in a string, and it's outputting an object. So parser, and this is get and private set again. And the reason why I'm doing string to an object and not creating a template parameter is because I want to be able to have a list of argument types. However, if that template parameter were to vary, I wouldn't be able just to have a list of generic argument types. It doesn't work exactly like that. Although I could do some research, but from what I figured, it did not go over too well. And then another thing is we might also want to, this is just an afterthought, but if you do type of integer, like the int, we're going to be doing string comparisons. So when we give a route, like say, when we give a route that's like, or when we say add a route to the dictionary, that's like /user/int. We're going to be doing comparisons on this integer, on this little thing enclosed in the braces, and we're going to try and compare this to a type, to the stored argument types that we have, because we'll essentially be associating argument types with certain routes like this. But if you do type of integer dot name, this is equal to int32. So we're going to also want to be able to specify some flexibility. And we can just do that by having a list of names that you can identify this by. So we'll have a public hash set of strings, alt names, and that's get and private set as well. Oops, my wires are getting all tangled. I'm sorry. Give me 2 seconds. All good. All right. So this hash set will allow us to store and just give us an efficient comparison. All right, and then we'll have the constructor here. So it'll be a private constructor because we're going to be essentially controlling all of these argument types, because we want to have a couple standard ones, but we also don't want to provide the flexibility to create duplicates. So for example, we don't want to have multiple integer argument types because that could get all messy. So we're going to just have a singular way to create this, and we will control it ourselves, and that will be done using a private constructor. So argument type, and we'll just pass in I guess I suppose we could you know, we can make this as a template constructor without actually passing in I believe we can. We can make, I'm going to check this, but can you? Do I need to make this public? Nope. Okay, I don't think that can work. So in the private constructor, we need to pass in a type. And then we're also going to need to pass in our custom parser, so string to an object. Once again, we want to avoid having templates here. And then just call that parser. And then we're going to have a bunch of alt names that you can specify beyond that. And we can do this using the params keyword. So params string alt names. And even though this is a private constructor and no one's going to be able to access it, we're going to have a static method to create a custom argument type. And we want to have an easy way to pass in the extra parameters that we give it through that static method. So we'll just set a couple things here. So type is equal to type, parser is equal to parser, and then we're going to initialize our alt names. So alt names is equal to new hash set string, and then we're going to say for each string alt name in alt names. So we're just going to iterate through all the parameters that we passed in. We're going to add them. So alt names, the class member dot add the alt name in the array, and then we also want to add the type name just because we're going to want to be able to, because if there aren't any alternate names, then we want to be able to just identify it by the type, because type of string is just string. Oh, I also meant to say this should be alt name dot to lower, just so we can keep everything concise and consistent, and we don't run into any case sensitive scenarios. So then we'll also say type dot name dot to lower here, like so. So these are the variables, and they're all set up. And we'll create the public, the static one, the static constructor later on. But for now, let's define a couple of these. So we're going to have a parser, or at least a try parser, in sorry, I am blanking. Yes, we're going to have a try parse method, which will be static, and that will allow us, and we're just going to pass in a string, and we want to take out a value and the type of the value just as it might be useful. So it's going to be a public static bool method because we're going to determine, well, did we actually find anything? And we'll say try parse, passing in the string value, and we're going to be outputting an object, so object value, and type. So we're essentially going to be trying to parse a generic object. We don't care what it is, but we're going to determine what it is through the type here. But we don't want to specify what type we want to get because in some cases we might not know. For example, again, when we have two possible types, we don't want to specify, okay, only get an integer because, or only get a string because that string could also be an integer. Yeah. And then, yeah, we also don't know if we're going to get anything, so that's why we're returning a Boolean. And then we return the type, which will allow us to identify what type the value actually is. Okay. So we're going to need we're going to need a list of standard ones, and it's going to be a private static dictionary, or a list rather. So private static list, well, I'll call it iList. And it's going to be an iList of argument types. We'll call it mappings, or sorry, we'll just call it arg types. It's equal to new list of arg type. And we want to specify a couple of standard ones, so we'll do a little initializer action here. Yeah, that'll work. We'll just return false for now in try parse. And it doesn't like it because we need to set that, but that's okay because we're not running anything just yet. So this list will be built in it'll be set up so that the higher priority objects are further down. So they're at the top of the list. We're not going to be using a stack because that can't work. We can't iterate over a stack. We'll just be saying the higher index objects have more priority, so we're going to scan those first when trying to parse an object. So the most basic argument that you can use is a string. And all we're going to be doing is we're just going to use the private constructor, so new arg type. We're going to pass in a type of string. And the lambda expression for the function will just be s to s. It just gets funneled through. And we can specify an alt name of just str. So this argument type, we're putting at the lowest priority because everything we get is a string. When we get a route from the server, we know that is going to be a string, no matter what. So we want to be able to rule out anything else before passing it in as a string. Oops. And then we'll do GUID. The order for the GUID doesn't matter just because the other ones are numbers, but I'm just going to put GUID above string because it's just a more specific string. So new arg type of GUID, and it's going to be s goes to GUID.parseS, and we don't need any alternate names. And the reason why I'm not I guess we could just say GUID.parse, right? Would that work? The wrong return type. Oh, yes, that is right. So the reason why we need to use a lambda expression here is because GUID.parse technically has a return type of GUID, but since we have our functions returning, the function delegate here returning an object, we need to explicitly make it a lambda function. And there are no alternate types. And then we'll also have double, so new arg type of double, and that goes to double.parse s, and we'll also be able to identify this using a float. And then below that, higher priority than that is actually the integer. Sorry. And the reason why is because, well, like I said, a double can parse an integer no matter what. But an integer, we sometimes want an integer rather than a double. So we need to put that at higher priority. Int.parse s. And then we also want to be able to identify it using integer or just int, because once again, the system name has the int32 in there. Okay. So once again, just priority rules. If you ever want something over an argument, you want to put it at a higher priority. So it just, the specificity, if that's a word, or like the nicheness of the argument increases as you increase index. So if we were just to iterate this from the bottom up, if we passed in the value 5, it would hit integer first and it would be able to parse it. If it was 5.7, well, integer.parse is going to throw an error, but we will see how that works. So integer.parse throws an error. So we can't do that, and therefore we go to the double, and it parses 5.7. If we pass in a GUID, we want to get it as a GUID above a string, and everything else just gets passed in as a string otherwise. All right. All right, let's create our try-parse method now, or implement it rather. So priority at top, as I said. So we're going to iterate from the top to the bottom. So for integer I is equal to mappings.count minus 1. I is greater than or equal to 0. I minus minus. Sorry, this should be argtypes.count. We're going to get our argtype saying var argtype is equal to argtypes at I. And then we're going to do a try catch here, because we're just going to call all the parsers, and if they throw an exception, we're just going to go on to the next one. So try catch, and then catch just continues. And in the try block, we're going to just assign values. So value, the output value, is equal to argtype.parser, and we're going to pass in value string. Type is equal to mapping or argtype.type. So this line will never be run if the parser throws an exception, and then we return true. Otherwise, we need to set some default values. So value is equal to null, type is equal to null, and then we return false. So this only gets run if we can't parse it. Never will happen, but just in case, because we might run into an exception while parsing a string. The only time that would happen would be memory or some other exception that happens, like a null value maybe. A null value is actually a great time that this would happen, but we would just return null, but also false. All right, so let's try this out. So we have this here. Let's go into program, and we will say console.writeLine, or actually, let's have our variables object value type, and we'll do console. Or actually, let's have a list of just strings to get our just so we can test it on a bunch of things. So we'll have say 57, 15, 57.5. Oh, also Boolean is something I forgot. Why not do that? That is a wonderful thing that we should be doing. Completely forgot about that. That's syntax error. It's new arg type of Boolean. S goes to bool.parse S. And I don't know what type of bool the type returns, but I'm just gonna leave it for now. Okay. We'll have true, a random string, and then we'll just say gwid.newGwid.toString. So just getting a random gwid. So we'll say for each string s in vals, we'll say argtype.tryparse s. We'll say out value and then out type. So we just output multiple values here. And we'll say if this happens, then we want to print it out. Oops. I suck at typing today. Oops, I also screwed up everything else. So if we get it, then we want to say console.writeLine. We'll do some string interpolation. So s goes to type.name. We won't worry about casting right now, but we will see how that works when we actually start doing the writing or the routing. All right, so console.writeLine that. Otherwise, we'll say console could not parse s. Okay. So let's run this. I suppose this shouldn't give us any problems. It's building, doing its whatever. Ah, something happened. I need to run this and have it. Do I need to do Control F5? Yes, okay. All right, nice. So we have int32, double, Boolean, string, and GWID. Wonderful. So I suppose we should also give Boolean an alternate name. That'll just be bool. Double as a float. But yeah, so we have, this is working properly. We're just giving it a string, and it returns the corresponding type based on the priority. And we saw that it returned the proper priority. God, I need to. It returns the proper priority. So 15 is recognized as an integer before it's recognized as a double. And I'll show you, if we get rid of the integer argument, I'll also just do the bool now. It will still recognize 15 as a double. It's just, with the integer, there's a larger priority, which is exactly what we want. Okay. So this is our tryparse function here. Relatively simple, just looks top down. All right, let's also have a function a couple functions to get specific argument types. So we have a tryparse function, which just parses a string. And then we also want to be able to get an argument type. Just in case we want to see if something does exist, or like an argument type if it does exist. So we'll want to pass in a type object or a string argument. So public static arg type get arg type arg type, and we'll say for. Oh wow, I completely botched this in my code. This should just literally just be return arg types dot where. So we're going to use some link expressions here. So where accepts a condition. So it will select any object from our list so long as the condition in where is true. So where a, and this accepts a lambda, so a dot, let's see, type is equal to arg type. And then we want to get dot single or default. And default means if it doesn't get anything, it's just going to return null. But that's the behavior we want. And then we also want to have public static arg type, get it from a string. So get arg type from a string. And we'll do some link as well, but again, we want to convert everything to lowercase to keep things standard. So arg type string is equal to arg type string dot to lower. And then the link is going to be very similar. So return arg types dot where a goes to, and we want to say a dot alt names dot contains arg type string, and again dot we're going to say first or default. Single or default actually throws an error if it gets multiple, so we need to make that first or default. My mistake. But yeah, just again, to lower standardized everything. We don't want any case sensitive stuff botching our parser. So these are just two quick methods to help us obtain argument types from either a string or the actual type of the argument. And we are going to use these. I'm just trying to... Oh, you know what? This method up here is not absolutely necessary. It's used for testing. Or actually, sorry, this one, where we pass in a type. It's not absolutely necessary. But we will do another parser method that uses this. So it'll be public static bool try parse, and this is going to be a template method, so we're going to try and parse a value string as a specific type. So out t value. So we have try, and we will say val is equal to t, so we're going to convert get arg type, and we'll pass in the type of t, and then we're going to get the argument type dot parser value string. So we're going to parse the get arg type here, or sorry, we're going to get the argument type from the actual type argument. We're going to get its parser and then try and parse the object, the string rather, and then cast it to the template variable, and then return true. But if this throws an error, we need to say value is equal to default and return false. That should not be else, that should be catch. So just in case we run into any errors with the parsing. What am I doing right now? We're doing some web server routing, or just HTTP routing, where you can pass in arguments like this, and we can actually parse the arguments as their types. And then we're going to be creating a tree that looks a lot like this. And we actually just finished the parser, but we're going to be getting into the tree object next. Sorry, give me 2 seconds. All right. All right, so this is our try parse function. You can try it out. We'll just try it out real quick right here. So we'll say if arg type dot try parse as a double, we'll say 15, There might be a framework in C# to do that, but I don't know where it is, and I also didn't bother to look. But this is also just something cool to look at. There's always libraries to do everything. Like, why make games if there are already games out there? Or it's just a very it's something fun to do. I like it. Just trying to look at how something was constructed, because the framework is cool and it works and it's perfect. It's tested. Mine isn't too tested, but it's just fun to write the code to actually do that yourself. All right, so we'll say console.writeLine 15 parsed as double. Yep, so we'll just try and run this. 15 parsed is double, 15, all good. So you can use that try_parse function to actually get a specific type out of there. All right, let's move on to the actual tree now. So we'll call this new class route tree. .cs, and we're going to be the larger class is going to be a route tree, but we're going to have a bunch of route tree nodes, and the route tree will just have a pointer to the root. But we're going to be able to do we want to have a wrapper class for this root that contains a couple other things, because we want to have custom functionality. Let me just explain this a different way. So we've done tree classes before, like say AVL. And in AVL, we didn't. I don't remember creating a wrapper class around the root. There was just a node class, and that's all you needed. And that was good because we wanted to do stuff recursively, and it was easy to do stuff recursively. So like with balancing, when you had that, and then you deleted this thing, you had to do something called rebalancing, which would then make it like this, so that the heights of both objects stayed within one of each other. And that was a recursive action. And traversing and inserting, that was all recursive. However, with something so linear as a string, when we know exactly the path that we want to traverse down, we don't need recursive actions. It's just going to increase our call stack. But when we're just doing a general traversal, yes, this would be good. And I suppose if we wanted to create a general traversal here, we could just use the route tree node class and have a recursive function. However, we're not going to be doing that. There's no real point unless we want to just print out all the routes, but we could, but we also don't need to. So we're going to have just one wrapper class, and then the node classes will have no functionality in them. There's going to be no we're going to have some getters and setters and stuff, but there's going to be no function in the route tree node will call another function, like a restructuring method or something like that. So we're going to have an inner class here called private class route tree node, which will contain functionality, getters, and setters. And then the larger route tree class will have a pointer to this route tree node, the wrapper class, and the wrapper class will have all the functionality in it. So we want to have a private route tree node root, and yeah, it will contain all the functionality here. Okay. Let's start with the route tree node class. We'll do something simple here. With each route tree node will be, we will specify a couple of things. So with each node, we can either have it just be a plain node, so there's no argument, or it's the result of an argument route. Either way, we don't want to have two classes. That's just going to get messy. So we're just going to have public arg type. This will be get and private set. Or actually, we'll just say set too, because we'll only be able to access this class from the route tree wrapper class. And then we will have an action corresponding to this node. So like here, up here, some trees had null actions, or some nodes had null actions, and others returned a page. So we want to have a function here. So function or public action. So action doesn't return anything. It just does something. And we want to pass in, oh, I suppose I didn't create this class, but that won't be necessary right now. So each action will take in a bunch of arguments, and we're just going to represent it as an object array right now. So we'll call it this action, get and set. So we're going to be passing in an object array because we can have multiple, and that'll be good. Okay. And then we will also have our dictionaries to actually map to children. So we'll say private I dictionary, mapping a string to a route tree node. And when we're mapping a string, we just want to map plain subroutes. So this is, these are just going to be mapping a route to a node. So, and then we also want to have our argument subroutes, so I dictionary. And this time we're going to be mapping a type, so the type of the argument, not an arg type, but the actual type. Although this type here will correspond to the arg type. So type in route tree node, arg subroutes. So if we go back to our diagram here, these are all going to be in the arg subroutes dictionary. These will all be in the plain subroutes dictionary because they don't depend on an argument. We don't need to do any special treatment to the actual route element there. We just need to take it as is. And if you want to further connect it to, or I guess that's the wrong word, but another thing that we'll be looking at is, well, what's the priority here? And it's always going to be plain subroutes. We're going to scan through the plain subroutes first, because those are hard-coded in. And we could also have a hard-coded value in for something like here. So if we wanted to do special treatment for an admin user is a good example. So we have a user. You can either get them by integer ID, or you can, or actually, you know, let's say, let's do the devices. So device, you can get it by an integer ID or a string, or let's just say you wanted to get the primary device. So that would be a special endpoint that would return special values. And we'd be able to differentiate it up here at this level, at the tree level, rather than having to do some more conditional action at the controller level. So we're essentially just trying to make, when we do end up creating endpoints and essentially the methods that we return these or send these actions, we want to make it as easy as possible and remove as much conditional action as possible. And this won't come at any extra cost because there are going to be a combination of plain subroutes and argument subroutes. This is just a specific case where it's going to, it's a side effect that's very beneficial to us. All right, so we have plain subroutes and argument subroutes. We'll have an empty standard constructor, so route tree node with no arguments, does nothing. We will also be able to say route tree node, which takes in an action. Oops, sorry. Action with an object array. So this is just for a plain route no action. This is going to be for a plain route with action. And then we will have an argument route with an action. So argument route with or without action. So you can either specify it or not. And that will be done just be giving an optional parameter here. So public route tree node, we pass in an argument type, arg type, and an action, taking in an object array. Action, that defaults to null. So we don't always need to. And this just allows us to not specify another constructor here. This constructor will, or actually, sorry, the plain route with action, we need to set our variables. So this action is equal to action. And then in the argument route, we can just call that constructor actually using this action. This is just a cool little feature that you see in C++ as well. But you can call other constructors passing in the actual action, whether or not it's null. And then we can also just say arg type is equal to arg type, the parameter. Okay. Alrighty. And you know what? I suppose... You know, we'll leave HTTP methods out of this until later. That'll be something else that we do. This is just route parsing. That'll be web server stuff. Web server specific stuff. Okay. So let us have let's create our setters here. So we're going this in the node. We want to be able to set our argument and plain subroutes. And we can actually, I forget exactly how to do this. Let me look it up real quick. It's, you know what, I'm going to try something. I'm going to try something here. So we'll say public override this square brackets, we take in string key. Does that work? No, it does not. Sorry, let me... Oh, okay. I was wrong. I was correct. There's no arguments there. So this, it should not be that. It's object. So this is going to be custom getters and setters right here. So we have public, sorry, this should not be object. This should be route tree node. I'm not sure why. Oh, yes. So this is an overrider. So we can actually just call root at whatever key. And then since we're doing a string key, we're going to have a getter, which will say, oops, just close out of that, did not want to. So the getter will be customly defined as, or sorry, no, the getter, I had an idea here, but I suppose this isn't working. You know what, we can do a setter for now. So set says if plain subroutes is equal to null, then we want to initialize the dictionary. So plain subroutes is equal to new dictionary, going from a string to a route tree node. And then we want to say plain subroutes at key is equal to value, and the value is a route tree node. And yes, that type is defined up here. And then for a getter, we're going to have a TryGet, and we will see why, but it will just help us a bunch with conditions. Yeah. So we shall say public bool try get plain subroute. We pass in a string element and an output route tree node RTN. So we will say if plain subroutes dot contains key elements. So if it contains the key, then we just return it. So route tree RTN is equal to plain subroutes at element and return true. Otherwise, we're going to say RTN is equal to this, and that's just going to be keeping the route tree node where it is and returning false. So the reason we'll see why we do this later on and we don't return null, but it's just this method here, try get plain subroutes, assuming that a function is kind of progressing. And if we can't find an element, then we just want to stay where we are and go to the next test. There is one caveat here. If plain subroutes is null, this is going to throw an exception, and we want to catch that. A very concise way to do that in C# without having to do a try catch block is just using null coalescators. I forget if that's actually how you say it, but you can make this a nullable value by putting a question mark there. So if plain subroutes, and this question mark says, okay, if plain subroutes is not null, then call this function and return it as a nullable Boolean. Otherwise, we're going to say it's just null. So if plain subroutes is null, don't execute this and just return a null value. However, we can't do a condition on that. There is no built-in way to do that. So we have to first get the actual nullable Boolean. So this expression here gets a nullable Boolean, which is just represented as bool question mark. And then we want to say get value or default. So get value or default will say if this nullable Boolean has a value, so if plain subroutes was not null, then we want to get the value that the function returned. Otherwise, we're going to say the default, which is just false. Okay. And we will do something very similar for the argument subroutes. So we'll do the setter first. So public, this should be public. It's going to be a route tree node. And we'll say this, and then this time we're going to be using a type key. So we will access stuff using or set stuff using a type key. All right, and we'll have the setter here. And once again, if arg subroutes is equal to null, then we want to initialize it. So arg subroutes is equal to new dictionary, mapping a type to a route tree node. And then arg subroutes at arg type, or at key rather, is equal to value. And then we'll do a try get method here. So public Boolean try get arg subroute. We pass in a type this time, and an out route tree node RTN. And the structure is going to be very similar to try get plain subroute. So if we're going to get the nullable Boolean in a parentheses. So if arg subroutes question mark dot contains key arg type, so that in a set of parentheses dot get value or default, we will say RTN is equal to arg subroutes at arg type, and then return true. I mean, actually, hold on. I'm thinking of something. Do this dictionary have a TryGet function? Let's see. Arg subroutes dot try get value. Oh, it does. Would you look at that? Okay. Yeah, so we can just say, make this completely concise and say this function, TryGet arg subroute, just funnels to arg subroutes question mark dot try get value. We pass in an arg type as the key and an output RTN, and that just funnels this out RTN. Says, okay, we're going to output it to the output parameter in the actual function, and then we need to convert this to a Boolean. So we say get value or defaults. Does that not work? What's going on? RTN. Oh. Okay, that's fine. So this out RTN might not be assigned to. So can we say this is equal to default? No. Okay. So we're gonna say instead of doing that, we need to do a conditional block here. So arg subroutes question mark dot try get value arg type and out RTN dot has value. So this is a Boolean if it has a value, and if it does, then we say return true because RTN was assigned to, and otherwise we're going to say, oh, I'm kind of getting foiled here. Sorry. Ignore that I did anything right there. We're going to redo this. So if arg subroutes dot try, sorry, let me rewrite this method. Writing in C# is so goddamn satisfying. I picked it up at the beginning of the summer for a job, but goddamn, it is so much fun. There's so much you can do with it. I love it. So we're going to say, let's see, if arg subroutes question mark dot try get value arg type, and we say out RTN, then we return true, right? Or this is dot get value or default. Sorry. So if that happens, we return true. What do you mean RTN isn't getting assigned to? Oh, that's stupid control flow stuff. I suppose this doesn't work. I was trying to do something fancy here because C# is so aesthetic, but I suppose this won't work. Okay, we just got to do it this way. So if arg subroutes dot contains key, blah, 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 yeah, we get it. So if it contains the key, we say RTN is equal to arg subroutes at arg type. And otherwise, we say RTN is equal to defaults and return false. I'm actually trying to, can I say RTN is equal to RTN and have that be valid? Ah, no. Unassigned out parameter. I'm just gonna leave it like this for now, because this isn't too fancy, and I'm like, I will try and I am currently studying computer engineering, but computer science is a big part of that. So I take classes in both fields, or I mean, I guess computer science is a part of it. So taking some computer engineering classes is equivalent to taking computer science classes, but it's more software engineering classes most of the time. All right, so this is our TryGet subroute function, and this is all we need for the route tree node class. We have just a couple accessors, a couple setters, and that's all we need. Let's go back to the wrapper class. So we have our root, and again, this root gives us access to all of these functions here. So let's add our route. So let's have a function called public void add route, and we take in a string route, and this is an action taking an object and an action here. Okay. All right, so first thing we want to do is if root is equal to null, then we say root is equal to new route tree node, like so. And otherwise, we're going to start moving through. So we essentially want to, so we're going to go back to OneNote. And I'm going to give us a very simple route tree. So let's say we had our slash and user. So let's say we want to, and we'll also say just home here. Let's say we want to add the route slash user slash integer. I'm mostly just messing around with C# networking, but it could be private use, although I don't know what the copyright would be there. So this is legally I'm messing around with it. Technically, I don't know if I'll ever end up using it, but for now it's just messing around. So user integer is our second element, and then we want to say device and integer. So let's say we want to add that, and let's say that user already has an integer endpoint here. So we need to break this up into elements. So we have user, the integer argument, and we have device, and then we have integer again, like so. And if we want to add this, we're going to add it one by one. So this is our first one, 2, 3, and 4, and we'll just essentially just go down. So when we start, we point to the root node, and then we want to find a path with the user, with the user route. So we need to check, all right, does it exist? And we see that it does. So we go down here, and now we're pointing to here. And then again, we need to check, all right, does the integer endpoint exist? And it does. So we move down, and now we're pointing to the integer. Now device, it doesn't exist, so we need to create it. Device, like so. And this actually returns, what network framework am I using? Right now this is nothing, but for the static file server that we did in the last video, it uses HTTP listener. But this is just generic, it can be used anywhere. So integer, this will return a page with the person. Device is null, so null action. And then we want to create another endpoint here on the device, which returns an integer. And once we're done with all the routes, we're pointing to here, and we need to attach the new action to it. So this will return, say, dev name for device name. And yeah, so that's just the way we're going to procedurally do this. And if we want to do device string, we would just add the other endpoint over here. And those can also both interact with each other, but from the tree's point of view, they're completely separate. So it doesn't matter. But the point is we're just going to be walking through the tree and we're going to be updating pointers, which is once again why I wanted to have this wrapper class. We don't have the need to do things recursively. Yes, the math visualizer is I'm going to be putting out a video next week. I will, yeah. We'll be doing transitions next, which will be quite fun. Yeah, so again, this is why I wanted to have the wrapper class, because there's no need for recursion. If we can just update pointers and not have to return, because recursion is useful if you need to return, or if you need to go along multiple paths or backtrack, like with traversals. However, when we're just doing a single determinate path that is well defined, then we don't need to have any recursion, and we don't need to allocate any extra stack memory. It just makes it easier to have it linear like this. Okay, so we will have a current node pointer, which will start at the root. And then we'll say for each variable element in route.split along the slash marks, or the slashes, not slash marks. And so yeah, this just splits it up into elements. And sometimes we may have an empty element, in which case we would just want to skip it. So if string is null or empty element, then we just go continue. And otherwise, we're going to start trying to create or keep track of the next node. So we're going to say route tree node, next node is equal to null. And then after some control flow, we're going to say current node is equal to next node. Like so. So we're going to do some stuff in between. So we first need to determine, all right, is this an argument? The only decision we need to make here is if this is an argument or a plain subroute. Am I planning any sort of game engine series, something like that? I feel like the OpenGL stuff, the OpenGL tutorial is pretty much an engine. It's not a game itself, no GUI in it, but it's pretty much it's a full engine. Go check that out if you would like. I will do the shameless self-promotion, but yeah, there's a series out for that. All right, so we're gonna have some specific way to determine if it's an argument, and it'll just be if element dot starts with an open curly brace and element dot ends with a closed curly brace. So this will just be the standard way to define, okay, well, this is an integer and the type is within that. So what we want to do now is string type string is equal to element dot substring, and we'll start from index 1, and then the length will be element dot length minus 2, because we're just going to be trimming off the 2 characters there. So we want to get the type string, or the type from the type string, and don't we have a function for that? Where is it? Where did I put it? Here it is. Here we go. Get argument type. So we're going to say argument type, arg type is equal to arg type dot get arg type, passing in the or just the type string. No, not C#. I have not done OpenGL with C#. it started out basic, but it's a lot. It's over 50 videos now, so I don't know if you can just start watching it now, but if you want, go for it. Have fun. Okay, so we have our argument type here that we get from the type string, and I suppose this could return an error, right? First or default, that could return null. So we need to say, you know what, we're not going to worry about the null check right now. I'll do that on my own time. So we'll say next node is equal to current node dot try get arg subroute. So we're going to try and get a subroute of the current node that matches it. So we don't want to create it unless we have to. So we also don't want to overwrite it. So if we have the argument type, then let's try and see if we have an existing endpoint there. So this is arg type dot type. We're just passing in the type there, and we want to output to you know what, can I actually, no, I have to do this. So actually, no, we're going to do output to route tree node RTN, and if this succeeds, then we want to set it to RTN, and otherwise we want to say new route tree node with the arg type there. So what's cool about with the output parameter here is that we can use it in a conditional expression in the ternary operator here. So we assign to it in the function call, and then we can just use it in the conditional here, which is very cool. And then next we want to set or actually attach the next node. So we say current node at, and the type is going to be arg type dot type, and we want to say this is equal to next node, and this is using the overrider of the index there. All right, otherwise we're going to have a plain route. So we'll do something similar, except we don't need to get the argument type. So next node is equal to current node dot try get plain subroute, passing in the element because we don't need to parse anything, so just the plain element, and out route tree node RTN. Oops, that should not be a curly brace. That should be a ternary operator. If it succeeds, then we just send it to the next node, and otherwise we create a new route tree node with no argument. All right. Wonderful. So that's just a plain route, and then we need to attach it as well. So current node at element is equal to next node. And then after all the conditionals, we say current node is equal to next node, and then once we have gone through everything, we need to attach the action to the endpoint that we want to set. So current node dot this action is equal to action, the one that we passed in up here. Okay, we will do the navigate function in just a second, but let's test this out. Let's go to program. So we've done our argument type parsing, but let's try doing this. So route tree RT is equal to new route tree. And sorry, hold on. Am I still, okay, I'm still good. I almost dropped connection. Okay. So we'll say rt.add route, and that'll just be a slash for now. And then let's create a couple. So we'll have some static endpoints up here. So we'll say static void action, and it takes in some objects, args. Actually, I should have done a paste bin, but we'll do it for now. So, or we'll just write it out for now. So console.writeLine action, like so. And we can just use this action name in the add route. So add route and just action without the parentheses. And this just gives us the actual, it just converts it to an action taking in object arguments. And we're going to change this and make it super cool in just a second. Oh, this is faster than regex? Don't ask me. Yeah, I'd heard regex finds routes, but I think this is, at some level there needs to be a tree or something of that sort. I'm not sure. Unless you're just storing a list of all the possible routes, and that'll do that. But I like the tree. All right, so we add the route here. Let's create a couple. We will say static void action hello object args. And this is console.writeLine action hello. And then static void action int, which takes an integer, we'll say. So object, it still has to take in arguments as an object array, but we're going to specify the route to take in an integer. And we'll say console.writeLine action int, and we'll just print out the element as an integer. So we'll say arg0, just like, or sorry, that's wrong, sorry. The integer conversion of args at 0. We're not going to see all this write line stuff until we actually do the navigate function, but we're just going to try and set up these endpoints now. And then we'll also have static void action hello test integer string object args. So console.writeLine. Here, let me just copy this in. And we print out the integer conversion of args at 0. And then also just args at 1 as a string. And then the toString function will just, we can actually just cast it. And then it will just give us the string value there. Okay. So again, these don't matter. I'm just going to configure the functions now just so we can get some visible output when we do the navigate function. Accept method, that will come when we do the dynamic web server. I'm just worrying about routing right now. And I will figure out what that looks like because it'll be interesting. Because you know what we could actually, I'm just thinking about this now. We could have a dictionary inside of the route node that it's not just this action, but a mapping of methods to actions. However, I need to test that. But that's I was considering that. I was thinking about your comment there. But I just figured that, all right, I thought of that idea. But we'll worry about that when we actually do the dynamic web server. Okay, so we add the action endpoint, and then we'll also do a couple more. So rt.addRoute /hello goes to action hello rt.addRoute /integer, and notice how I'm putting it in curly braces, action int, and then rt.addRoute /hello /test /integer /string, and this will just take in that whole thing there. All right, so I'm going to do a debug here and just visually inspect it. I know you guys won't be able to see it, but I'm gonna try my best to show you guys what it looks like. All right, so breakpoints set up. So we have our route tree, and I'm going to step over the last one. So we have our root, and it has, I wish I could zoom in here, but I'm just going to tell you guys what I see. There is a count of 1 argument subroutes and a count of 1 plain subroutes, and this action has a you can look at the name here, and it corresponds exactly to what we passed in, which is good. So this action is getting set properly. Argument type is null, so it's a plain subroute. Plain subroutes, it maps the string hello to another route tree node, which has did I screw something up? Oh, right, yes. Hello has this action, but it only has 1 plain subroute as test, and test has no action, and it has no plain subroutes, but it has 1 argument subroute. And if you look at that argument subroute, then it also doesn't have an action, but it has an argument type of integer. You'll see, and you can just go on and do this for all of them, but that's just what you should expect. So you just go through it and go through the mappings and make sure that the argument types are set properly, and also that the subroutes are also configured properly. But the debugging will work fine. I just don't want to spend 5 minutes trying to read everything out to you. All right, so we have our routes configured, and now let's try and navigate to these routes. So if we want to pass in a route, say / like that, or / hello, and we want to see what the output is when we pass in these routes and process them by the route tree. Yeah, let's do that. So we need to go back to the route tree class, and we're going to create a new function below add route, and that will be if that just defines the type of the parameter. I'm not sure exactly how to do correspond them to names, but we're going to do something cool once we get the navigation working. But we will see how we can customize the names, but not in the routes, but in the curly braces, that is the type there. All right, so for navigate, we're going to start with public bool navigate. So we pass in a string route. And we're going to say if root is equal to null, then we're just going to return false. Or let's say try navigate, because why not? Okay, and then we'll do query parameters afterwards. Not right now though. All right, so here we're going to do something very similar to what we did in the add route. We're going to have a current node, so variable current node is equal to root, except this time we're also going to keep track of some arguments. So variable route args list is equal to new list of objects, and then we're going to say for each var route element in route route.split with along these slashes. And once again, we'll have a null check. So if string dot is null or empty route element continue. And otherwise, we're going to get the we won't do that just yet. The escape stuff, because we're not going to consider that case right now. But some routers. Yeah, I know that exists, and I'm gonna try and see if that would work, but we will see how we can name the variables in the actual endpoints, and that's gonna be something cool that we look at in a second. So if the string is null or empty, then continue. Otherwise, we're going to say if current node dot try get plain subroute, because remember we're giving priority to the plain subroutes, passing in the element and out current node, then continue. Sorry, this should be route element. So what is the line here? So we say current node, which is the node that we're currently at, and we're going to try and get a plain subroute. And if we do, then we just go on to the next one because there's no other action to be taken. We don't have to parse anything. We simply just get the plain subroute. There's just an error there. The route element is what we have, and then we output to the current node. So we don't need to assign anything here. And so that in the next iteration of the loop, current node points to the plain subroute. However, you might be wondering, well, let's look at the argument subroutes. Well, don't we need to stay at current node? What if this doesn't output something properly? And if you remember, TryGet plain subroute returns this if it doesn't find it. Like I said, this is assuming that you're trying to move forward in the tree and you might want to move on to a different possibility. So it's just going to make it simple and return the current node as the output here, so that we can just move on to the next conditional. All right, and then else if we're going to try and parse an argument here. So we need to, if we want to determine if it's an argument subroute, then we need to determine two things: that we can actually parse the element, and then we need to try and get the argument subroute corresponding to that element. So arg type dot try parse, it's going to be route element, and we're going to out an object value and also output a type. And this type will allow us to get the argument subroute. So current dot try get argument subroute, type and out current node. So we say here current node dot try get argument subroute, like so. And if all goes well, then the current node will be moved up to the subroute, and we also have a value that we need to add to the list. So route args list dot add value. And then otherwise, else we're going to return false because we don't have a valid route. Nothing was found. All right, and then once we are all done, current node points to our endpoint that we want to call or invoke. So we're going to do a try catch here, try and catch just to make sure, well, if some conversion goes wrong, we're just going to do it right here. So current node dot this action route args list dot to array, and then we return true, and then catch. We'll do some fancy stuff. You could do some fancy stuff here, but we will just return false. Okay, so let's do it. Yeah, so if we call routes now, it will call the navigate function. And if you want to get some deep understanding, you can walk through the debug. Let me just walk through the debug with you guys. So we will do some console.write lines here. rt.navigate or try navigate along the route slash. We'll do slash hello. We'll do slash integer. We'll do slash string. Sorry, this should be an integer value, 15. The string value will just be blah, 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 blah. It's invalid. we'll also do a double, 15.5. And then we will also have hello slash test slash 17 slash blah, 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 blah. Music, yeah, music ended. All right, you know, and let's just run this to see if it works, and then I will walk through the debug with you. Okay, so what we saw is action got printed out true, so it found it. Action hello, also true, so it found it. Action int 15, it got an integer and it parsed it properly. False on the invalid string argument and also false on the double argument because an integer cannot parse that. And then this thing printed out as 17 and ASDG true. Exactly what we had here. Funny and cool and wonderful. Let's walk through some debugs. Let's do the slash, and then we'll also do something wrong, and then the large route. Does control F5 not allow me to debug? What am I missing? All right, so let's just do this. Try navigate. Oops, why did I do that? I screwed up, guys. Okay. You know, let's do the hello one. It'll actually be cooler. So if root is equal to null, then return false, but we have a valid root. So we start at the current node, and the current node has a plain subroute and an argument subroute, and we want hello. So we initialize our list here. And then for each, we have for each element there. And you can see that the route element will start as just an empty string because it's trying to get something before the slash and then also after the slash. So it's just empty, and that's why we have to continue here. And then otherwise, we're going to try and get a plain subroute. So let's walk into this one. So in plain subroutes, we're trying to find the element hello. And then we are going to index into the dictionary, and we found one, so we set the return route tree node as just the element at that the node at that endpoint there, or at that subroute, and then return true. All right, and if we do, then we just go continue, and we go to the next element. However, there's nothing else, so we want to call the action associated with the endpoint, and that's going to be here. We're going to pass in the array, and we return true, and you can visualize the output there. Action hello. All right, let's try and get the invalid one. So try navigate. Good, good, good. Continue past the blank one. So we try and get the plain subroute associated with the string first, and it doesn't work. So now we're going to try and get an argument. So we do argument.tryParse, and we look at, I forget what the argument type is for first. Arg types is, what just happened? Oh yeah, it's all good, don't worry. So continue. Sorry, let me do that there. Continue. The argument type is nothing. I don't know why it's doing that. I'm just gonna do that there. So we're at the double one, then we're at the GUID, and it can't parse it. So then we go to the string, and it can parse it. So it sets the type and returns true. And then we need to do TryGet arg subroute using the argument value. So arg type is going to be a string, as you can see in the debugger there. And then we try and get, and we try and find a key corresponding to the string, and we don't. So we just set default values and return false. So therefore, we need to just return false there. All right. Now for the last one, hello test 17, blah, 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 blah. So we do hello first, and that's just going to be a plain subroute. So we go to the next one. And remember current node gets set in the try methods here. Test is also a plain subroute. And then we try and get the integer 17. So that gets added to the list of arguments. And then go to the last one. It's also an argument. It's a string. So we add it to the list. And now route args list has two things, an integer and a string. We're done with it. So then we call the action with the two arguments. And we're bing, bang, boom, we're done. All right. So that's routing. We're going to now do a couple of cool things. And we're going to make this a little nicer to look at. So we don't want to get object arrays. We want to actually be able to specify, hey, I want a string. Or I don't want any arguments. So for example, I just get rid of that. And I don't want that either. But for the integer, I want an integer number. And Abdul, this is where we're going to name the actual variables in the parameter list here. So num. And then we'll also, in this one, we want to take in a number. So int num and a string str. So num and then str. So right now we can't build because there's a bunch of errors, but we're going to do it. We're going to do something cool. So I don't forget if, hold on. Let me find the, let me find this. Let me go here. Okay. So I have in my paste bin, or I created a paste bin that I linked below. And what it does is it just defines 16 custom methods that we can use to add routes with a variable number of arguments. And these are all template methods. So let me just copy and paste it in. So I made it as a region so you can hide it. But it's very ugly. But this is the grunt work that needs to happen. I actually created a script to do it, and that script is also linked below. But in route tree, we'll just put it down below, so like there. And I named add route as the underscore, so we just need to make this here an underscore. And then I also added a web server as an object just because I was testing it, but suppose that's not very appropriate anymore. So let me do something very quick. Let me revert that paste. Let me look at the script with you guys real quick. So let me I'm just going to comment out all of this. And I'm going to find the script that I should have already had pulled up, but I'm being very unprofessional right now. All right, so this is our script that we use to print it out. And just put it down there. So we essentially just create the function name here. That's the function name, and it just joins together all of the numbers that we have. And then we just need to get rid of the web server keyword there. We don't want to pass in the web server at all. And we just want to pass in the raw arguments. So let's run that. And here we go. So we have, I suppose you could do 15 now because you can have in an action delegate, you can have a total of up to 16 parameter arguments. But with the web server, we were restricted to 15. But for now, we can just do this. And I'm just going to copy all of them. And I'm going to paste them down below. Or actually, we're going to do a region. So region templates add methods. And then end region. I'm not sure why the indentation got all screwy. Oh, you know why? I probably screwed something up with the test, with the script. All right, let me go back to program here. Oh yeah, it didn't paste it properly. Okay, that makes more sense. So I want it to be how many in? So we have add route, which I will make a private method now because we don't want to be able to just add it like this. So I need it to be 2 indentations in. So that's 2, and I want the rest of it to be 3. Like that. Okay. Now if we run it, let's just copy and paste into route tree. Okay, this should be all good. Couple of errors, but I'll fix that in a second. So these functions, methods, they simply are add route, and they take in a variable number of template types, and it just calls the add route function, and all it does is it creates another Lambda function that will call the action that we want. So the add route function requires an action that takes in an object array. So that's what this Lambda is. So the Lambda takes in an object array, but the custom action with the template parameters that we need, we're just going to cast corresponding elements to their values using this custom little function that I'm going to paste in and have a second. But yeah, so object is the object array. The action is the actual custom action that we're passing in, which has the custom arguments. And then we say object.get, and we want to get the 0th element as that template argument. And this get function is actually what's called an extension method. So I will paste it in and then I'll describe it to you guys. But essentially, extension methods are defined in static classes. So it's a static class, and then we have a static method. It returns t. It's a template method. It's called get, and then we say this, meaning you can call arr.get, which is what you saw down below, but this arr just needs to be of type object array, and we want to get the element at the index, and we just do a check here. So if it's less than, then we cast it, otherwise we return default. So object.getTo just says get the 0th element and cast it to type TO. And all these TO, T1 through T15, these are just template parameters. All right, so now let's try adding these. So I will comment this script out, uncomment all of this, and we will get a couple of errors. KU. Okay, so add route. Oh, I forgot. The one other thing that we do need to add that's not accounted for in the script is the one with 0 arguments. So that's just going to be public void add route, takes in nothing. You just pass in a string route and an action, and that just returns add route, and then action. Sorry, the Lambda just needs to go to just call action because the object array will be empty. So action. So we're just calling the custom action with no arguments at all. Even if there are, we don't really care. We don't want them. So that takes care of this one and this one, but for the other ones, we need to specify our parameters. So integer for the first one here. And then for the other one, it's going to be integer and then string. like so. And then now, in these custom endpoints, we don't need to do any casting. We can just take these variables in as they are. So let's do some control F5, and voila, it works just as before. And it's pretty fast too. I was testing it and it was a little slow. I don't know. It definitely had something to do with the templates. There were just too many in there. But yeah, that is all fun and good. This video is going on for quite a while. I'm going to do a follow-up to this video, where we will deal with query parameters along with the thing that Abdul suggested, which would be mapping HTTP methods to different endpoints. And he gave me an idea, so I'm going to work on that next couple days, and then I'll probably do a video. And then just a heads up, this week I'm going to be going back home for a month after this week, so I'm going to have a couple of videos that will be scheduled to come out, but I will not be doing any live streams, but I will also be available to be contacted through Discord or email. So I will have a computer, but I just won't be able to record. So yeah, that is all I have for you guys today. I hope you enjoyed and hope you learned something. I will be back within the week with the next video following up to this. But yeah, until then, enjoy yourselves. And I will see you guys next time. Have a good one.